let's talk about the edit distance. Distances play an important role in machine learning and therefore also in artificial intelligence. We use distances in algorithms to be able to measure how close we are to a solution, to see if there is a huge error or not. We also use distances when we run clustering algorithms to be able to say that two objects are close to each other, or on the other hand, that they are far away. And finally, we need distances to be able to create an environment around solutions or around objects, and therefore to be able to deal with noise. You can have noise in the data and you can have noise in the solutions, and distances allows you to measure the quantity of noise you are handling. There is a case for distances in texts. Texts are, of course, very important because there are huge quantities of texts on the internet, and therefore there are a number of issues and machine learning problems dealing with texts. One of these is translation. And when you think about automatic translation, you typically would like to measure the quality of a translation system by seeing how far away the sentence your machine translation has given you from the object that you were supposed to have had. So you want to be able to define distances and measure distances over texts. How do we do that? In the case of texts, we can have questions like, which is closest? Is clam closer to brain or is it closer to oyster? We can see that it is a difficult question. If I think from the semantics, perhaps a clam is really close to an oyster because they are both related to the sea. But if I look at it from the point of view of words, the point of view a printer may have, then clam is closer to brain because the number of errors, misspelling, that you would have made to go from clam to brain is much smaller than the number of errors you would have made to go from clam to oyster. So we are going to think about a distance which is actually measuring the number of errors we are making when transcribing one word when we were thinking of another one. So if we want to measure the number of errors we are making when writing one text instead of another, we will count what is called edit operations. There are typically 3 edit operations. The first one is deletion. I have forgotten a character. For example, I was wanting to write main, but I have written man, so I forgot the I. The second one is the opposite. It's called insertion. So I wanted to write coin, but I wrote Colin, so I inserted an N. And the third operation is substitution. I replace one letter by another letter. Example, I wanted to write teach, but I wrote beach. Each one of these operations counts as one error. And what I'm interested in is on calculating how many errors have been needed to go from one word to another. This is called the edit distance. The edit distance is the smallest number of edit operations that are needed to go from one word to another. So it is in a way the length of the smallest edit path to get from one word to another. The example I have given here is on words, but it works exactly the same thing on phrases or on texts. We will be counting how many words we have had to insert, to delete, or to substitute to get from one text to another text. Example, the distance between 1 and 10 is 3, because there is a path of length 3, which is 1 is transformed into on by a deletion, into tn by a substitution, and then from tn we go to 10 by an insertion. Of course, this is not a proof that it is 3. This is a proof that it is at most 3. Perhaps there is a better solution. Can you find it? No, you can't. There isn't a better solution. There are algorithms that allow us to find the optimal solution. And you can compute a more complex distance between the man and a woman and see in how many operations you go from one to the other, notice here that the blank is taken as a letter. Of course, this edit distance is not the only way to build a distance between words or between texts. I have showed it because I think it's a very well-known distance, and it shows you how you can compute distances between complex objects. A more important one very used today is called the cosine distance. And here the idea is a little bit more complicated. You have got two sentences, and each sentence will be made into a vector of a very high dimensional space. What I mean by that is that for every sentence, I will count how many times each word appears. And I will do the same in the other sentence, and then I will be able to match these dimensions. How many times does the word the appear? How many times does the word man appear? How many times does the word saw appear? And so onwards. And by comparing these two values, which can be seen as vectors, I can calculate the angle of the vector, and the cosine of the angle will actually give me a good indication of how similar or how different the two vectors are, and therefore the two texts are. This is a distance that is very much used in machine learning.